Welcome. In this video, we'll explore the famous solid principles and truly understand how each one helps you write cleaner, more maintainable software. We'll define each principle, share a quick analogy, then walk through a JavaScript code snippet, showing you what to avoid and how to fix it. Let's get started. Single responsibility is about focus. Imagine having a Swiss Army knife for everyday work. It can do everything, but it's a bit clumsy. Instead, specialized tools get the job done more reliably. In code, if one class handles too many different tasks, any change in one task might break the others. In the bad example, one class juggles user creation, emails, and reporting. Any tweak in the email process might break user creation logic or mess up reporting. By splitting them up, each class remains easier to maintain and less prone to unexpected side effects. That's the power of single responsibility. Picture having an electrical outlet where you can plug in new adapters. You don't rebuild the outlet each time, you just add a specialized adapter. In code, this means you design your classes so that new functionality slots in seamlessly, rather than hacking up the entire class. If your class is stuffed with if-else clauses for every new payment method, you'll keep modifying it. That's prone to bugs. Instead, you can accept different strategy objects for each payment type. This way, when a new payment method comes along, you just create a new strategy class, leaving the original processor untouched. That's a perfect illustration of open for extension, closed for modification. Imagine you have a bird that can fly. If you replace that bird with an ostrich and your code calls fly, you'll have a problem. Liskov Substitution ensures subclasses truly match the behavior their parent promises, so you can swap them freely without code chaos. In the first snippet, we let an ostrich inherit from bird, but bird's fly method makes no sense for an ostrich. That's a broken substitution. By splitting flying bird and non-flying bird, each subclass meets the exact expectations of its base. No more fake flyers. Think of an all-in-one appliance that combines a coffee maker, a printer, and a toaster. Sure, it does everything, but if you only need printing, you're stuck with a giant contraption. Interface segregation says to break these tasks into separate interfaces or classes, so clients only rely on what they actually use. If all you want is to start and stop a machine, having brew coffee and print document cluttering your code is overkill. By splitting them into engine, coffee maker, and printer, each client only imports the methods it needs. That makes your code more flexible and less confusing. Picture a car with a universal slot for the stereo. The car doesn't care if it's a cassette deck, a CD player, or Bluetooth. That's because it expects an interface, not a specific brand. In code, this means injecting an abstraction so you can swap concrete implementations freely. In the first example, user service is locked into MySQL database. If you switch to MongoDB, you'll have to rewrite the service code. In the improved version, you inject any database object that implements query. Now, swapping databases or using mocks for testing is a breeze, all thanks to depending on an abstraction rather than a concrete class. We've covered each solid principle with detailed definitions, fun analogies, and JavaScript examples showing how to avoid pitfalls. Remember, keep classes focused, open them for extension without rewriting, ensure subclasses meet parent expectations, break down giant interfaces, and inject abstractions instead of depending on concrete details. Put this into practice, and your projects will thank you. Happy coding!